Hello, welcome to the 10.5 video, which is about effects of doubling dimensions of surface area and volume, doubling the dimensions on the cubes and cylinders and the prisms and everything. So what you see before you is a 1 by 1 by 1 cube. Okay, what's the volume and surface area of a 1 by 1 by 1 cube? That's what we're going to address today. Easy questions to start off with. For the cube, the volume is 1 times 1 times 1, which is just 1 cubic inch. But what's the surface area? Surface area means if each side is the length of 1, the space would be 1. But in this shape, now we have how many different sides there? Okay, so the answer here, a 1 by 1 by 1 cube has a volume of 1 cubic inch and a surface area of 6 square inches. 1 cubic inch, 6 square inches. There we go, that's a little better. So what happens if we actually double the lengths of this cube? Not just doubling it, and instead of turning one, having 1 cube, now we have 2. That's not actually doubling the cube. What we actually want to talk about is not just having 1 cube now, but doubling the sides. So it's not 1 by 1, it's now 2 by 2 by 2. The length, width, and height are 2, 2, 2. So that's what I want to take a look at next. And we want to look at what's the volume and what's the surface area. So here's our next shape. Let me zoom out a little bit here. What's the volume and surface area of a 2 by 2 by 2 cube? So now, as you can see, just from looking at it, this cube certainly has more than a volume of just 1. And more than a surface area of doubling 6. So the volume of this cube would be how many cubes are there total? And let me just show you. And how many total cubes do you see there? There should be 8. So it's 8 inches cubed. Now the surface area of this would be, well, let's add all these up. We have 4 on this side, and then 4 on the opposite side, behind it. And on this side, there's 4 groups of 4 around, and then 1 on top and bottom. So it would be 4 times 6, which is 24. So the surface area is now 24. So the question we're trying to address is, what's the difference between a surface area of 6 and then 24? And also, what's the difference between 1 and 8? Because both times we just doubled it, but you can see the numbers got much bigger. 6 to 24 is more than doubling it. So we're going to actually look at that today. If we take this series one step further, what does that cube look like now? Think in your head, how many cubes right now would have, now if we double this again, instead of 2 by 2 by 2, what if we have 4 by 4 by 4? How big is that? Well, here it is. Whoa, big guy right there, right? So that is now a 4 by 4 by 4 cube. The volume is pretty big. The surface area is pretty big. So we're going to talk about that effect, but doubling the sides or dimensions actually has a pretty big effect on what you see, or how many, what the volume and surface area actually become. All right, so we'll close that. So here's that question once again. The question we're trying to focus on today: what effect does doubling the side lengths of a 3D shape have on the volume and surface area? It obviously gets a lot bigger, but it actually gets more than just doubled. So that's what we want to look at today. So we'll look at just a couple examples. We're going to start talking just about a shape that's a cube that's 2 by 2. So we'll talk about the surface area and volume of those. So here we go. We'll go ahead and draw a couple examples here and find the surface area. But if this is a 2 by 2, this is 2 inches, 2 inches, let's just look at the surface area first. So looking at the surface area of a cube here, we want to just find how many, what's the surface area of this whole cube. Now each of these faces of a cube, if each face is 2 by 2, it's pretty easy for cubes. There's 2 by 2 and there's actually 6 of them, because a cube has 6 different faces. And if they're all 2 by 2, it makes it nice and easy. So to find the surface area, we have 4, just multiplying these out, base times height. We have 4 of each of those. If you add those up, 4 6 times is 24. And that's what I just showed you before. The surface area is 24 inches squared. Now if we look at the volume of this cube, of a 2 by 2 cube, what we want to do now is if I erase this, remember we want to, for volume we want to outline the base and then draw in the 3D height, which would be going up here. Once again, all the dimensions are 2, so it would be 2, 2, and 2. If we do V equals capital B times H, the area of my green square is 2 times 2, which is 4. So capital B is 4. The area of this base is 4. The 3D height is 2, so 4 times 2 is 8 inches cubed. So here the surface area is much bigger. So now we're going to take that shape and actually double it. Now all the lengths are going to be 4. This is that big stack of cubes that you saw before. So just like surface area, we have 6 identical faces. All of them, each face is just 4 times 4. So we'll do 6 4 times 4s. And go ahead and do that on your own there. See if you can figure out quickly what's the surface area of all the different faces here. So when we do all the math here, we get 16 for all the faces, and there are 6 of them. So if you do 16 times 6, you'll get your answer pretty quickly. 16 times 6. 16 times 6 is 96. If I did the math right there. Alright, so if we take a look at now the volume of this cube here, oops, too much. If we take a look at the volume of this cube, we'll find the area of the base, highlight that base, and then multiply by our 3D height. Again, these are all 4. So we'll start with our formula for any 3D prism or cylinder, capital B times H. Our area of the base here, this 4 by 4 shape, is 4 times 4, which is 16. And our 3-dimensional height is 4. When you do the math there, 16 times 4, you get 96 inches cubed this time for volume. So what I want you to do is look at the relationship between surface areas when we double it. What's the relationship between 24 and 96? How much bigger is that? And then I want you to figure out what's the relationship between 8 and 96. How many times bigger is 96 than 24? And how many times bigger is 96 than 8? Well, to answer that question, we're going to divide our bigger by our smaller, 96 divided by 24. So if you do 96 over 24, divide that, you actually see that this is times 4. 24 times 4 is 96. If you do 96 divided by 8, you get 12. Well, that's not right. 96 divided by 8. 96 divided by 8. Oh, sorry. That's why I did this wrong. Hopefully you figured the mistake there. My apologies. 16 times 4 is actually 64, not 96. Sorry about that. Yeah, if we do 64 divided by 8, we get 8. That's what I was looking for, times 8. So we're going to look at that relationship there. Now next we're going to look at cylinders, see if the same thing happens or if a different thing happens. For cylinders, we'll do surface area first, and then volume. So remember the radius is 4, and the height is 4. So for this question, I think you had it drawn in there as well. To find the surface area, we're going to do pi r squared, which is pi times 4 squared. And we have 2 of those circles. Remember, we're trying to do both circles and the rectangle. So pi times 4 squared is 50.3, and we have 2 of those. And for the rectangle part, remember that's circumference times the height. Circumference is pi times diameter, or pi times 8, times our height of 4. And that gives us 100.5. So if we add those numbers up to find the final surface area, add all those up, we get a surface area of 201.1 inches squared. Let's see how much bigger the surface area gets when instead of a radius of 4, it's now 8. It's doubled. A lot of people will think it just doubles, but it actually doesn't. So we're actually making this cylinder a lot bigger. So we'll do surface area again. Pi r squared, which is pi times 8 squared. And we have 2 of those. 2 circles, top and bottom. So what we'll do is plug that into the calculator. Pi times 8 squared. We get 201.1 for both of those. And then when we do this rectangle, we do circumference times height. Pi times diameter is pi times 16 times the height of 8. When we do that, we got 402.1. So to find the surface area here, we add up our yellow numbers there. 201.1, 201.1, and 402.1. I got 804.3 inches squared. So now if we look at our relationship here, what's the relationship between 201.1, let me do that in green actually. What's the relationship between 201.1 and the surface area when we double it? 804.3. You should see that, just by straight numbers, 200 to 800, it's about times 4. Okay, so we're actually multiplying it by about 4. Oh, sorry, I meant to do that in pen. And if you notice, that times 4 is exactly the same thing that happened up here. So we multiplied it by 4 both times. Kind of a weird pattern there. To figure out the cylinder, we're going to do volume now. And volume's a little bit easier because the formula is not as complicated once you understand it. Capital B times H, our area of the base, this time it's a circle. So we're doing pi times r squared times our 3-dimensional height, which is 4. And then below we're also doing capital B times H, which is pi times 8 squared now, times our 3D height of 8. Go ahead and multiply those out for me, see what you get. When we do that, I got about 201.2 and then 1608.5, rounding it. So what's the relationship between those two numbers? How much bigger is it? It's a lot bigger, actually. If you divide 1608.5, if you divide 16.08 or 1608.5 divided by 201.2, you actually get about times 7.99 or something like that, about times 8 again. So you can see that when we're doubling the volume, it's actually being multiplied 8 times for surface area or for prisms and cylinders, but when we're doubling the dimensions of a cube for the surface or for surface area, it actually is just multiplied by about 4 times. So I want you to try to summarize your findings right here. For a cube, what happens when you double the surface area? And for a cylinder, what happens when you double the dimensions of the volume there? Thanks for listening, guys. We will see you tomorrow.